Hi, in this video I want us to take a second and a deeper look at vector subtraction. Here we have two vectors, p and a w. This vector is the result of subtracting w from p minus w. This is the best way to visualize vector subtraction. If I have two vectors and I want to subtract one from the other, I simply join them at the tail, and then the difference runs from the tip of one to the tip of the other. Now where does the arrow go? Well, if it's p minus w, the arrow points at p, and if it's w minus p, the arrow points at w. So this is w minus p, and this is p minus w. Let's look at the intuition behind our little rule for vector subtraction. P minus w is the same as saying negative w plus p. Let's say that again. P minus w is the same as negative w plus p. So here we have negative w and p, and now this is vector addition, right? I'm adding negative w to p. But notice my result is still what? P minus w. So you can do this if you forget the rule, but the rule should be easy to remember. P minus w, join the vectors at the tail, and then if it's p minus w, we draw a vector between these 2 points and the tip of the difference. This is the difference vector. Remember, difference is a subtraction, is at the tip of p. And if it's w minus p, well then this tip comes over here. Here we have w minus p, and this is the same as negative p plus w. So there we have it. Negative p plus w gives me what? W minus p. So this should let you understand how we came up with the little rule for vector subtraction. W minus p, the difference vector points at the tip of the vector w. So this rule should be easy to remember. Now let's look at how we actually carry out the subtraction, how we actually do the calculation. Very often when you work with vectors, those vectors will be expressed in terms of a magnitude and a direction. In this case, the directions are specified as angles, measured counterclockwise from the positive x direction. The first thing you're going to need to do is calculate the scalar components for these vectors. Fortunately, this is very easy to do in GeoGebra. Remember, however, that you need to be able to do this manually using the definitions of the sine and cosine. So for this vector, the scalar components are 2.14 and 2.48. In other words, px is 2.14 and py is 2.48. For this other vector, wx is 4.22 and the y component is 0.6. So all we need to do now is subtract these 2.14 minus 4.22 and 2.48 minus 0.6. This gives me, of course, minus 2.08 and 1.88. So that's this vector. This vector has an x scalar component of minus 2.08. I'm not showing the vector components, but you should be able to imagine them. That's a vector pointing this way, and 1.88, that's a vector pointing up. Of course, if we want the magnitude and direction of this vector, we simply apply Pythagoras and use the definition of a tangent. But since I'm in GeoGebra, I can do this very easily. And so this vector has a magnitude of 2.8 and is at an angle of 137.89 from the positive x direction. So this should be fairly easy for you to do. Finding w minus p is pretty much the same thing. We find the scalar components for w and p, and then we carry out a little subtraction. 4.22 minus 2.14, 0.6 minus 2.48, which gives us 2.08 and negative 1.88. So this goes across 2.08 and down 1.88. Of course, we can also get the magnitude and direction. So notice the magnitude is the same, only that now the vector points in the exactly opposite direction. P minus w points in the exactly opposite direction as w minus p. So that's it for this video. We will carry out our calculations using scalar components, but we'll visualize what we need to do drawing the vectors. Okay, so that's it for this video. Bye for now.